Today, we're talking about an invisible gas that is literally all around us, but chances are you barely think about it. Its name actually means lazy. But as you're about to see, that inactivity, it's its greatest superpower. So let's start with a bit of a riddle. What on earth could an old light bulb, one of the most important documents in history, and a modern window possibly have in common? I mean, they seem totally unrelated, right? Well, they all share a secret guardian, an unsung hero that helps them work better and last longer. And the answer, of course, is argon. So here's our game plan. We'll start by properly meeting this so-called lazy gas. Then we'll uncover the science behind its power. After that, we'll see how it acts as both a priceless protector and an invisible insulator, and wrap things up by looking at its role as a true unsung hero.
All right, first things first. Let's get properly introduced. What exactly is this lazy gas, and where in the world does it come from?
Well, you're breathing it in right this very second. Argon makes up almost a full % of the air we breathe. That makes it the third most abundant gas in our atmosphere. Now, I know that number might not sound like a lot, but just wait until you see how it stacks up against some other gases you've definitely heard of. Yeah, this really puts it into perspective, doesn't it? At over 9,000 parts per million, argon is more than 23 times more abundant than carbon dioxide, and it's over 500 times more common than neon. It's been hiding in plain sight this whole time. You know, the story behind the name is perfect. The scientists who finally isolated it back in 1894, Lord Rayleigh and Sir William Ramsay, they named it argon from the Greek word argos, which means lazy or inactive. Why? Because they were absolutely stunned to find a gas that just refused to react with anything, and as we'll see, that's its most important trait.
But, the discovery didn't happen overnight. People suspected it was there for over a century. Henry Cavendish had a hunch way back in 1785, but it wasn't until 1894 that Rayleigh and Ramsay finally proved it. And get this, for decades, its symbol was just A, before it was officially changed to R in 1957.
So, what is it that makes argon so lazy? What's the secret? Well, the answer is deep in its atomic structure, which takes us right to the periodic table. See, argon belongs to a very exclusive club, the noble gases. They're over on the far right of the periodic table in group 18. You can think of them as the VIPs of the chemical world. They're stable, they're non-reactive, and they generally just like to keep to themselves. It really all comes down to electrons. With shells of 2, 8, and 8, its outermost shell is completely full. Now, most chemical reactions happen because atoms are trying to gain, lose, or share electrons to get a full outer shell. But argon? It already has one. It's perfectly content all by itself, so it has almost zero reason to bond with other elements. And that amazing property, that tendency to not start a chemical fight, has a name: chemical inertness. And as we're about to see, this so-called laziness is exactly what makes argon so incredibly useful.
Okay, this is where it gets really interesting. How do we take a gas that does absolutely nothing and turn it into such a powerful and versatile tool? Let's go back to our light bulb. That tiny tungsten filament inside gets incredibly hot. If it were surrounded by regular air, the oxygen would just tear it apart in seconds. But if you fill that bulb with inert argon, the filament is completely safe. Argon creates this perfect, non-reactive shield, which extends the bulb's life by a huge amount.
Now, this same idea of protection applies to things that are way, way more precious than light bulbs. Think about the U.S. National Archives. They have this constant challenge. They have to preserve these priceless documents, but they also have to let people see them. And their biggest enemies are oxygen, humidity, and just time itself.
Which brings us to the Constitution. Since 2003, America's founding documents have been sealed in these incredible custom-designed cases filled with pure argon gas. The argon pushes out all the oxygen and moisture, creating a totally inert atmosphere that pretty much just stops the clock on the chemical reactions that cause the ink and parchment to break down. What's really interesting is that before argon, they used to use helium. But here's the problem. Helium atoms are so tiny that they could actually leak out through the seals over time. Argon molecules, on the other hand, are bigger and heavier, which makes them much easier to contain. It just provides a more stable, long-term protective shield.
But argon's protective powers don't just stop with historical artifacts. It's also working silently right now in a lot of our homes. If you have modern, energy-efficient windows, there's a good chance you have argon in your house. The gas is sealed between 2 or even 3 panes of glass. And because argon is denser than air, it dramatically slows down the transfer of heat from one side to the other. It's basically an invisible, insulating blanket tucked right inside your window. This chart really shows you the difference. It's looking at thermal conductivity, which is just a fancy way of saying how well something lets heat pass through it. For insulation, you want a low number. So air has a conductivity of about 26. Argon, it's all the way down around 17.7. That drop makes a huge difference in keeping heat out in the summer and in during the winter. But that brings up a really practical question. If it's completely invisible and has no smell, how do you even know it's there? And the truth is, you can't, not without some specialized equipment. And that's why quality control when these windows are made is so absolutely critical to make sure you're getting the performance you paid for. So let's bring this all together. What's the big takeaway from our look at this unsung gaseous hero? Well, we've seen that its laziness makes it an amazing protector for everything from light bulbs to historical treasures. It's an invisible insulator in our homes. And it doesn't stop there. It's used as a shielding gas in high-temperature welding to prevent defects. And it's even used to keep packaged food and wine fresh by pushing out the oxygen. And just when you think you've heard it all, here's one final, truly mind-blowing application. Argon helps us tell time on a geological scale. See, a specific isotope, argon-40, is created by the natural radioactive decay of potassium in rocks. So by measuring the ratio of that potassium to the argon that's trapped inside, scientists can accurately date rocks that are millions or even billions of years old. From preserving the ancient past to insulating our modern future, argon is just this perfect example of a hidden force, quietly making our world work. And it really makes you wonder, doesn't it? What other invisible forces are out there, hiding in plain sight, quietly shaping our world every single day?